Alright, so the subject of this video is covalent bonds. I've already done a separate video on ionic bonds. This is the second type of bonding that we need to be aware of. And as it says, a covalent bond forms when a pair of electrons is shared between two atoms. Ions were always formed when electrons were transferred. That's not the case now. We're looking at covalency. We're looking at electrons being shared between atoms. Now, why would two atoms share a pair of electrons? Well, let's see what we mean by sharing. It's when both atoms forming a covalent bond put an electron, if you like, into the center, into the middle, so that both of them have access to two electrons. Two atoms, one electron each, into the middle, both have access to that pair of electrons. That's a covalent bond. Now, we've seen that metal atoms can donate electrons to non-metallic atoms. That gives both atoms having that stable noble gas electronic configurations, and that makes them stable. That's fine when one atom loses electrons and the other one gains. That's the case when we have a non-metal reacting with a metal. As we have, non-metallic elements all gain electrons to get full outer shells. So, my non-metallic elements cannot form ionic bonds with each other. Not going to work. Atoms of both elements need to gain electrons. But they can gain full outer shells by sharing. That's the formation of a covalent bond. And very important to remember, molecules are produced. Molecules are only produced when we have covalent bonds. Small section of the periodic table. I'm looking at the left, lithium Li, sodium Na, potassium K, magnesium Mg, calcium Ca, all metals. That rule IUM at the end indicates to me that they are metallic. On the other extreme, I'm looking at number 9, F, fluorine. Below it, Cl, chlorine. O, number 8, oxygen. Underneath that, S, sulfur. These are the non-metallic elements. So metallic elements are found towards the left. They're not going to interest us with covalent bonding. It's the non-metallic elements towards the right. Non-metallic elements then can react with other non-metallic elements. They can share. They can make these covalent bonds. Two metallic elements can never bond together. They both have atoms that will lose electrons. And if you think about it, if I just pick two non-metals, hydrogen and chlorine, I can make them bond together to make hydrogen chloride. The name gives it away. It tells you what atoms were involved in making the bonds. I would never get something like two metals, sodium and magnesium. Sodium magnesium, no, it doesn't work. Sodium magnesite? No. Two metallic elements can never react together. We'll be looking at some examples of making covalent bonds in a couple of slides. But the formation of single bonds by sharing electrons is the way to show that. It always involves sharing pairs of electrons, leading to noble gas configurations. Noble gas configurations meaning full outer electron shells. Never forgetting that's what makes atoms stable. Now, we call these diagrams dot and cross diagrams to show covalent bonds. Dots or small circles represent the electrons of one atom. I don't always use dots. Crosses represent the electrons of the other atom. Simplest example. Two hydrogen atoms. I didn't even bother to draw the electron differently. Hydrogen, atomic number 1. 1 proton, 1 electron. If the two electrons in the separate hydrogen atoms go into the middle, the atoms overlap. Both atoms now have access to the two electrons, outer shell full. Though my two dots belonged to the hydrogen atoms, they're now bonded together to form a hydrogen molecule, H2, noting that term, molecule. We only use the term molecule if we're looking at covalent bonds. Another example is with a chlorine molecule. Now there am I saying crosses represent the electrons of one atom, dots represent the electrons of another, and that works. I've highlighted the colors of my electrons in the outer shell of my chlorine atoms. Red for one, green for the other, and when they overlap, I can see that the overlapping involves one green, one red, one from each atom. Both chlorine atoms needed to gain one electron because chlorine's in group 7. Remembering back, chlorine in group 7, 7 in the outside shell, needs to get to 8 by sharing. Both atoms get there, both become stable. Now, they had 7 valency electrons, they now both have access to 8. But it doesn't always have to be just 2 atoms. Water, we all know and love, H2O. Hydrogen, atomic number 1, 1 proton, 1 electron. I've got them in green here. Oxygen, group 6, 6 valence electrons. Now the oxygen atoms will need to gain 2 extra electrons to get that full stable shell of 8. And we can do that by showing the 2 hydrogens overlapping. Both hydrogen atoms now gain 1 extra electron. That's a full inner shell of 2, stable. The oxygen atom, in interacting with the 2 hydrogen atoms, also gained a full shell of 8. Carbon, another example. Carbon, if we looked at the periodic table, group 4. If I go back up, group 1 begins with lithium, 2 beryllium, 3 boron, 4 carbon. And so what we got there is carbon, 4 electrons in the outside shell, 4 electrons need to be gained. Hydrogen, as we've always seen, 1 electron in the outside shell, 1 needs to be gained to give a full inner shell of 2. And that means that the carbon atom is going to have to overlap with 4 separate hydrogen atoms so that the carbon gets that full outer shell. And that gives me my chemical formula, CH4. Yeah, I could have described that formation of CH4 as making a molecule. Covalent bonds means molecules are there. Now, I've said lastly for simple covalent molecules, none of it's that complicated. The bonding in hydrogen chloride is simple to predict. Chlorine, group 7, I've drawn the electrons in red. Hydrogen, 1 electron, and by drawing the overlap, chlorine putting 1 electron into the covalent bond, that's the shared pair of electrons. Hydrogen putting 1 in also, both of them get a full, stable outer shell. Another. Atoms can share more than 1 pair of electrons. Why not? It's all about atoms getting a full, stable outer shell. Why not share more than 1 pair if that works? Nitrogen's in group 5, check. Group 5, lithium 1, beryllium 2, 3, 4, nitrogen is 5. And if nitrogen is in group 5, both nitrogen atoms in a pair have 5 electrons. If they have 5 electrons, 3 need to be gained. They can both become stable by sharing 3 pairs of electrons. Now that's called a triple covalent bond. Yep, makes sense. There are 3 pairs, 3 covalent bonds in there, and you could summarize it quite easily. This will be useful just by drawing the lines. The lines between the 2 nitrogen atoms show me there are 3 covalent bonds there. Carbon dioxide, CO2. Carbon is in group 4, oxygen is in group 6. Lithium 1, beryllium 2, carbon is in group 4. Keep counting. Nitrogen 5, oxygen 6. And if my if my carbon there, group 4, 4 outer electrons drawn in black. Oxygen 6 outer electrons, we can see. Oxygen atoms needed to gain 2 and so shared 2. The sharing is always fair. It's always even. Carbon needs to do that with 2 oxygen atoms to get the full outer shell of 8 that it needs to become stable. And I could replace those diagrams, the dot and cross diagrams as they're called, with just 2 lines on either side of the carbon. Same with oxygen. As we've already seen, oxygen group 6, 6 in the outside shell. 2 oxygen atoms can combine together. They share 2 pairs of electrons. Both now has access to 8. Oxygen on the left, I've got the 6, what you want to call them, dots or circles. Originally, now has access to 2 electrons shown by crosses. They came from the other oxygen atom. That's 2 bonds. I will draw 2 lines between the oxygen atoms. Just to add, oxygen would always be written as O with the subscript 2. 2 are bonded together. Carbon dioxide above would be written as C, O with the subscript 2. 2 oxygens needed. Getting a little bit more complicated now, but as complicated as it ever will be. This compound ethene, which we'll get to know when I make a video on organic chemistry. It's got chemical formula C2H4. Carbon atoms can always make 4 bonds. Hydrogen atoms can make 1 bond. Now, that being the case, a line between the atoms represents a covalent bond. If I'm drawing something complex like this, I would always draw using the lines to show the covalent bond first. If I go to try and draw the structure on the right with all the electrons drawn in, that's going to be difficult, starting from nothing. But the fact that I've drawn my simplified structure first, carbon making 2 bonds with the other carbon, both carbon atoms also bonding to 2 hydrogens, that gives each carbon atom 4 bonds, each hydrogen atom 1 bond. That works. And now I can use that to draw the dot and cross diagram if I need to, if I'm asked to. Hydrogen electrons are shown in red. 1 red electron in each of the 4 bonds between carbon and hydrogen. In the middle, carbon atom on the left had black dots to represent its electrons. Carbon atom on the right had black crosses. My first diagram, my simplified diagram, showed 2 bonds. 2 bonds means 2 pairs of electrons means 4. There's my complete dot and cross diagram. As I say, carbon atoms, the electrons are shown in black, X showing the electrons from one carbon atom, dots showing the electrons from the other. And my little red circle shows electrons from the hydrogen. All atoms, the important thing, all atoms get full, stable outer shells. One more example. This compound methanol, and already people will be looking at that and thinking, oh, what? CH3OH, but the way it's written actually helps. I know carbon atoms need to make 4 bonds. I know oxygen atom, oxygen group 6, needs to make 2 bonds. Hydrogen always 1. The fact it says CH3 shows me I can begin with a carbon bonded to 3 hydrogens. The CH3 is actually a help. What's left is O and H. Now the oxygen must be bonded to the carbon. Hydrogen only makes 1 bond. I can't use it to connect 2 atoms to other atoms together. Having got that diagram, I look to the one on the right. If I'm asked to draw a dot and cross diagram. Now my hydrogen electrons are shown in red, with the carbon, electrons of carbon shown in green. I've got 4 pairs of electrons for the carbon around. 3 of those pairs involve the hydrogen atoms. That's the CH3 part. Then the carbon is bonded to an oxygen. I see the line. That's my little helper. Oxygen electrons drawn in blue. There's a blue and a green in that shared pair. And finally, oxygen will have its last electron, its 6th electron, making a bond with hydrogen. So really there, my message on that one, draw the simple structure first, even if you're not asked. Use it to guide you and help you to draw the more complex one. Now that's looked at the formation of covalent bonds to make molecules. The properties of simple molecular compounds can be explained by considering bonding. Always, when we think about the bonds that are formed, the nature of those bonds, they help us to predict the properties. And we're required to know covalent substances have low melting and boiling points. What we saw in a previous video, ionic substances have high melting points because of the attraction between oppositely charged ions. I don't have that now. Poor electrical conductivity. I'm going to go further than that. I'm going to say no electrical conductivity. No electrons are transferred when covalent bonds are made. You could think covalent as cooperate. The atoms share electrons. No charged particles. They never conduct electricity. The attraction between molecules can be called intermolecular forces. Inter means between. Intermolecular forces, forces of attraction between molecules. They're not strong. There's nothing positive, nothing negative. No opposites attract here. So the molecules can be separated easily. That means they have low melting and boiling points. They boil easily. We say they are more volatile than ionic compounds. No. Quick question. Nitrogen and chlorine form a compound with the structure shown. Which row gives the type of bonding and the chemical formula? Take your time and then I'll explain. Well, I look at the lines. The lines represent covalent bonds. Goodbye A, goodbye C. And I look at how many nitrogens and how many chlorines are involved in the whole structure. 2 nitrogens, 4 chlorines, that's N2Cl4. A is the winner. For number 2, complete the diagram to show the arrangement of electrons in a molecule of water, H2O. You will almost certainly remember by now. Oxygen in group 6. 6 outside electrons. Hydrogen with only 1 electron. And from there on, you can figure out what needs to be shared so that both oxygen atoms and hydrogen atoms get full stable outer shells. Next example, carbon dioxide, CO2. I see the overlap. Carbon in group 4, oxygen in group 6. I need to figure out how the electrons will be shared. Now, to answer that question, I've just taken pictures that I had earlier. That's here. There's my oxygen, 6 electrons drawn in red. Doesn't matter what code you use, although examples will often tell you. Hydrogen, electrons drawn in green. I've got my bonds. Oxygen atom now with access to 8 electrons, full outer shell, stable. Hydrogen atoms, 2 electrons fill the inside shell. It's full for both atoms, it's stable. Carbon dioxide, carbon group 4. I've drawn my carbon electrons with little crosses. I've drawn my oxygen electrons with little red dots. And I need to realize that carbon 4 to start with, 4 electrons to start with, the 4 crosses. The carbon atom needed to gain 2 electrons from each oxygen. Well, that's making double bonds with each of the oxygens. I could, if I wanted, write C in the center, double bonded with 2 lines to each of the oxygens. One more question. How many different elements are present in this thing methanol? Again, we'll look at methanol when we do organic. C2, carbon, that's an element. H5, hydrogen, that's another element, that's 2. O for oxygen, that's 3. I've already counted hydrogen, so the one hydrogen at the end, no need to worry about it. I've got 3 elements, that gives me 4B. Next video, I intend to be on the more complex covalent structures. They're called macro. Macro means big. Macromolecules. That I intend to release at the same time as this one. And on the subject of the videos being released, please consider hitting the button that says subscribe. That doesn't cost anything, but it just helps YouTube to know that people are watching the videos. That helps them to realize that people are taking it seriously. And it will take you and give you access to all of the videos as they're released. I think this is my 3rd one. I'm guessing it's going to be about 80 that need to be made to cover biochem and phys for IGCSE, but I believe that if you're a subscriber, you'll be notified when more come out. Hope that was useful. I'll get on to the next video. Thank you.